In question 4, I'm giving you that x plus 2 is a factor. So x plus 2 is a factor, and we want to find the other factors of this, of which there should be 2 because it's a third-degree polynomial. So what we said we're going to do is, if we know the factor is related to the 0. We always have to divide by the 0 of the function. So we've got to be able to go from factors to zeros very fluidly. So in order to do that, what we can always do is we know that factors are the things that we set equal to 0. Factors are set equal to 0 to find solutions, and solutions are your zeros. So that means that x equals a negative 2 is your 0 that you're going to divide by. So we're going to divide by negative 2. And we want to divide into the polynomial. We have a 1x cubed. We don't have any x squareds. We have a negative 8, and then we have another negative 8. And we're going to divide it synthetically by negative 2. So we bring down the 1. 2 times negative 2 times 1 is a negative 2. Add them up to negative 2. Negative 2 times a negative 2 is a positive 4. Add it together is a negative 4. A negative 2 times a negative 4 is a positive 8. And we get a remainder of 0, which is what we would expect because they told us specifically that it is a factor. And if it's a factor, that remainder has to be 0. Now this started out as a third-degree polynomial, and when we find a factor, then we depress it to a 1-degree lower polynomial. So really what I have is an x squared minus 2x minus 4. That's my new polynomial that I'm trying to solve and find the factors of. Well, if I want to find the factors of this, I simply set it equal to 0, and then I got some choices here. This is a quadratic equation. I could possibly factor, but that's going to go to the wayside very quickly, but we can use the quadratic formula in all cases. There are no factors of 4 that are going to add up to a negative 2 or even subtract to a negative 2. So I'm going to find the factors, or at least the zeros, correct that. I'm going to find the zeros of this by using the quadratic formula. So we're going to take the opposite of b, which is 2, plus or minus the square root of b squared, which is 4, then minus 4 times a times c. So it's a negative 4 times 1 times another negative 4. That'll be plus 16, all over 2 times 1, or 2 times a, which is 2. So this is going to be 2 plus or minus the square root of 20 all over 2. So I'm going to find the zeros and then convert these zeros back into factors. So that means x is equal to, I'm going to distribute my division. It's 2 over 2 plus or minus, and I'm also going to take care of that perfect square factor in 20, which is 4 times 5 all over 2. Well, the 2 divided by 2 is 1, then plus or minus the square root of 4 is a 2 times the square root of 5 all over 2. And these 2's can reduce, so it's 1 plus or minus the square root of 5. Now these represent the zeros, or the solutions, to your equation. They aren't the factors, but we can get the factors. If you remember the relationship between zeros and factors that I pointed out here, if you know the zeros, then there's a relationship between the zeros and the factors. The factor is, you set factors equal to 0. If I have the solutions, then what I want to do is take these. It says my answer for x is 1 plus the square root of 5. I also have another answer when x is 1 minus the square root of 5. When we want factors, we want to get it set equal to 0. So I've got to subtract the 1, and I want to subtract the square root of 5. So 1 minus x minus 1 minus the square root of 5 equals 0. Once I get this set equal to 0, that's my factor that we're looking for. This is a 0. To convert it to a factor, you simply solve it and set it equal to 0. So minus 1 equals a negative square root of 5. Now it's x minus 1 plus the square root of 5 equals 0. So my two solutions, my two factors that I didn't have, were the x minus 1 minus the square root of 5 and the x minus 1 plus the square root of 5. And the factor that I already knew because they told me it was a factor was the x plus 2. So here's the complete factorization of that third-degree polynomial. This is what I'm after. I'm searching for those 3 factors, the linear factors of the polynomial.